We've had a very difficult year in the summer rainfall area here in the north, with lots of late rains and lots of poor quality grain. Up to 30% of grain harvested in the last season was below grade, whereas it's normally below 5%. So before we getting into the season, and since we still have time for you to do something about it, if this continues to be the same season, we like to talk about grain drying. We're going to cover the drying facilities, drying systems available briefly, and then focus on in-bin drying systems. Of course, the easiest option is to leave the grain on the field, but of course that has its challenges. So often we are forced to do something about it. Grain quality is the best right on the field after maturity. But with wet fields, soil that doesn't dry out, can't get into the fields, it becomes a problem. So Marion will talk a little bit about the options available today.
Okay, let's kick off with the reasons why you would want to dry. Mario touched lightly on that in the beginning. The first reason to dry grain, of course, is to keep it safe, to store it safely. Right, the higher the moisture content is of the grain that you're putting into the silos or putting into storage, the lower the time is that you're able to store the grain. That's due to higher bacterial activity, higher insect activity, and fungus activity in the grain at higher moisture contents. For example, at average grain temperature of 15 degrees, which is typical for South African harvesting conditions, grain is able to last in a silo for up to 4 years if it's at 13% moisture content, but only 2 months if it's at 18% moisture content. If we go into summer and you keep storing the grain for longer, that reduces from if the grain is at 21%, if the grain temperature is at 21 degrees Celsius, your storage is about 2 years at 13%, but it's just 1 month at 18% moisture content. So these are massive disparities that just show how important storing grain at the correct moisture content level is. So you'll see here on the screen, we've got a little table that shows you just what the safe storage times are at different temperatures and different moisture contents. The second reason, as we said, is less molds and aflatoxins. So drier grain is much less likely to develop molds and fungus when in storage. And then drying grain reduces on-field losses. So just because you're getting the grain off the field quicker and earlier, losses associated with theft, with birds pecking away at your crops for small seeds like wheat and sorghum and so on. And then, of course, animal damage from the porcupines and their friends. Then, of course, also that insect damage. The third reason is increased productivity. By being able to harvest at higher moisture content, you are able to start harvesting earlier, taking advantage of higher market prices at the beginning of the season, as well as having more time available to finish harvesting all of your fields. As we saw in the 2025 season, if farmers were able to get into the fields earlier before the late rain started, the quality of the crop would have been increased significantly. So being able to dry allows you to get into the field to harvest during critical time windows. So even if the grain hasn't dried on the field completely yet, you'll increase your profit margins by delivering a better quality grain. If you're able to get the grain off the field earlier, and this is especially for farmers who are doing 2 crops a year or who are under irrigation, you don't have the luxury of waiting for the grain to dry on the field before you get the next crop in.
But of course, drying grain is not a cheap exercise. There's capital cost, and there's energy cost, and of course, drying energy cost and electricity cost involved. So you did a little bit of research on what the cost of grain drying is going to be.
Yeah. So, as a quick rule of thumb, this will vary a little bit between manufacturers of drying equipment, but it's always around that 1 liter of diesel per percentage point per ton of grain that you're going to be drying. Sometimes it'll be 0.9, sometimes it'll be 1.1, but it's always around that. If you add a little bit of electrical cost here, typically you'll be spending about 2 kilowatt hours of per percentage point per ton that you're drying on electrical costs. That'll be handling, recirculating costs like that. So, for example, if you're going to be drying a ton of grain from 18% to 14%, you'll be using about 4 liters of diesel, because that's 4 percentage points. And at today's diesel price, that'll equate to around 72 rands per ton in fuel.
But if you compare this to commercial grain traders and central silos that have been charging up to 390 rands a ton for a grain, and that's from 18 to 15%, right?
Yeah, from 18 to 14%.
18 to 40%.
For 4%. So they are charging 4 times the cost.
$400 is 4 times the cost, and the reason is they don't really want to do it.
They don't want to do it. They don't want to take in wet grain. Most of the co-ops and the grain handling companies in South Africa have very old dryers. They're busy looking at upgrading their dryers. But most of them have old dryers that are not efficient and that are at very low capacity. So they don't really want to take your wet grain.
And it's a critical time. They're busy. And nobody has time to wait for grain to dry. So as we know it, in many of these depots, they have a shortage of storage space even. You know, it's going into bunkers and silo bags and things like that.
Yeah. Then we can get to the different types of drying. So we have basically they're split up into 2 types. One is batch type dryers, the other one is continuous type dryers. So we'll start off with batch type dryers. The easiest and the most cost effective way of doing batch drying would be to do ambient or low temperature in silo drying. So other than field drying, if your drying need isn't that great, if you just need to take off maybe 2 or 3%, you just need to get it off quickly, you want to just get a little bit of an edge on when you're starting to harvest, you're able to do this. So it's relatively inexpensive. What you would need is you need a silo, you need a full aeration floor, and you need a grain spreader in that silo.
Preferably also some kind of a monitoring system, right?
It's good to have the monitoring system in the silo for temperature monitoring, but because you're doing low temperature drying, you don't really have a risk of heating the grain up too much when you're doing the low temperature drying. So low temperature drying, that would be the important thing here is you got to have the right airflow to do that. So airflow, we're targeting between 0.3 to 0.5 cubic feet per minute per bushel per minute per bushel, right? That translates into metric to around 300 to 500 liters of airflow per minute per cubic meter of storage space in the silo. Now, the air that can be used can be either natural or ambient air, and the ambient air can be heated up by about 10 degrees Celsius safely without having to add any additional equipment. So by adding the heat to the air, you're just able to increase the efficiency of the in-bin drying without increasing any risk of damage.
And this will just be done by with a burner.
Yeah, so you can just add a gas burner or diesel burner with
the aeration line.
Yeah. So you just add on a heater, diesel, gas, biomass.
And you need a heat exchanger for that?
For the gas dryer, though the gas burners, you don't need a heat exchanger because the gas burns clean. But for diesel and for biomass burners, you will need to add a heat exchanger just between the flame and the fan, just so that you get clean air in there. It's a good point. So some manufacturers and some suppliers will sell you a diesel burner, just what they would call a direct fire diesel burner, where you are directly firing into the fan from the diesel burner.
But then you've got problems there, possibly with overheating and with fire starting.
Yeah, overheating and fire starting, not massive issues there, but the problem there mainly is that you're getting smoke into the grain. So you're going to get a diesel taste on the grain. You might be, if the diesel burner isn't burning cleanly enough and isn't running at high efficiency, it's going to leave black marks on the grain that you're pushing through. And that's just residue of the diesel fuel that's in there.
Not good.
That's not good. And if processors get that and they get the diesel smell on the grain, they will just directly reject your load.
All right. Coming from low temperature in-bin drying, we're moving to high temperature in-bin drying. Of course, there's some kit necessary to do that. You can't just introduce all this heat into a silo full of grain. So, what do we need there?
So if we're doing high temperature in-bin drying, we have to add a stirring machine. So what the stirring machine does, it just basically mixes all the grain continuously while you're pushing the hot air through it. And by doing that, it does two things. It increases the airflow, so you get about 30% better airflow through the grain by using the stirring machine. So you actually have to use smaller fans to get the same airflow through the grain, or you are just spending less time getting the same amount of air through the grain. Second thing also is the stirring prevents what will happen is prevents it that the air will create little pathways in the grain if it's not stirred that it wants to pass through. And what will happen in these little pathways is the air will actually start heating up excessively, and you'll start getting heat and stress cracks on that grain that are in the way of these paths. Second thing is you're going to get over drying in spots and under drying in other spots. So you have the stirring machine, which is basically suspended from a rack on the sidewall of the silo and suspended from the peak of the silo by usually a chain or a cable. And this machine just moves all the way around the circumference of the silo, and the augers bring grain up from the bottom to the top, and they move inwards and outwards as well. So you'll see here there's a little display that we made of the stirring pattern that the dry stirring machine will run through.
And what heat are you talking about there?
Here we can go up to about 65 degrees Celsius heat pushing of the air pushed into the grain safely without causing heat stress cracks and without causing damage to the grain.
Okay. And then the process goes like this. Once you start filling your silo with grain, you start drying immediately, and you introduce the air. So as every batch goes in there, of course, there should be a grain spreader at the top that'll spread the grain evenly through the bin and not provide a heap in the middle of the bin.
Yeah.
Okay, so you start and you do this in layers. As each load comes in, you carry on with the drying, but you start right away once the first load hits the silo.
As soon as the first load's in there, you start up the fans, you start up the heat, you start up the stirring machine, and you just keep on running as you fill up the silo. On the advantage with the stirring machine compared to with the just normal low temperature drying, with the stirring machine you can put in grain into your silo of up to 30% moisture content, which is very high, without running a risk of damage. It takes a lot longer to dry, of course, from 30% down to 13% or 14%, but you are able to do it. So you're able to actually take the grain off at 30%.
And what size silos can we use this in? And of course, we can use this in existing silos. So we can retrofit this in existing silos. But we got a bit of a constraint with the diameter of the silo, and of course, a height that we can use, that we can go with that.
It is. So on the diameters, we can go anything from an 18-foot diameter, around 6 meter, up to 48 foot, which is 14.6 meter diameters. The limitation here is we can't have the stirring machine higher than 7.5 meters off the ground level of the silo.
Yeah, the augers are not stable at higher levels.
At high levels, yeah. And that just basically prevents the augers from starting to drag. What you don't want to have is the augers starting to drag and to turn sideways as they are moving through the grain.
So what's a maximum batch you can do in one of these bins?
On the 48-foot bin with 7.5 meter height, you can do about 850 tons.
And let's say we bring grain in at 20% and we want to bring this down to 13 or 14%. How long is that going to take on an 850 ton batch?
To do an 850 ton batch from 20% to 14% with a dry stir using 65-degree heated air, you're probably going to spend about 42 hours. So you'll be doing at max capacity about 20 tons per hour that you'll be able to dry in that silo.
And that's pretty good. That's a good drying rate. The advantage also, of course, of this of the dry stir is that you still have the storage space available after you've dried. You've got that 850 ton. Interesting, a question for you. After you've dried this, you've gone to a maximum of 7.5 meters, but the silo has got a height of, let's say, or peak height of, let's say, 50 meters. Can you fill this up with grain again without taking the stirring machine out?
You can. There's a little bit of a limitation on that. It has to be on a relatively slow outload speed silo that you're going to do that, or you have to limit the unloading speed on the silo a little bit, just until you've cleared the stirring machine.
You don't drag the stirring machine down.
You don't drag the stirring machine down. So you got to limit your unloading speed to around 50, 60 tons per hour till you've cleared the stirring machine. So that's just going to be the top 5 or 10% of the silo. And then after that, you can just open up and start unloading quickly.
All right. The next way to do this in bin drying is top dryers. Top dryers are not very popular around the world. It works. It has several limitations. Well, let's see how it works first.
Yeah, so top dryers are basically specially designed silos. They have a double roof cavity. So they have the normal roof, and then underneath that normal roof, they have a second roof. So you'll see on the picture that we've got displayed now, it's got these bands in there between the lower roof and the top roof. Those bands are leveling bands, so that causes the grain to lie in an even heap across the silo top. It's a very expensive roof because you've got to carry that entire mass of grain on that second roof, so which makes the structure pretty expensive. What then happens is warm air is blown through the grain at the top of the roof, and the grain is heated and the grain is dried in this batch. It's typically pretty small batches that you're doing.
Okay, and you're using relatively small silos for that. 24-foot to 36-foot bins maximum.
Yeah.
Yeah. So yeah, it's a small batch. And then of course once the grain is dried up top there, it's released through valves and it goes to the floor of the silo, and then it's cold air is introduced in there to cool it down as quick as possible also. Of course, the cold air also assists in drying the grain further down. But it's a specific bin. It's not a normal bin. Old bin or an existing bin cannot be retrofitted with this.
No, it's impossible to retrofit a bin to take a top dryer. In that, either you have a top dryer or you don't have a top dryer.
And I've heard that you've got a lot of rust problems in there, in the top drying bins.
On that lower roof level, you do have rust. I've heard of rust problems on that because you have this wet grain that is lying on the roof continuously, and while it's dried, and there's a lot of humidity being created on that small part.
Yeah, that's a solid roof there.
It's a solid roof.
It's not perforated.
No. The other issue that I also have a little bit with top dryers is just based on their capacity that they are always stating. They are stating capacities based on 90 degrees air that you're blowing into the top of the silo, which isn't really feasible in these types of silos because you don't have any mixing happening in that batch. There's just 90-degree air being blown onto it.
So you got stress crack issues then.
Definitely stress crack issues. So it's better to look at the capacities that they are stating on their bins at the much more 70-degree air that you're putting through, which reduces the capacities a lot on what they are, what the stated capacities are.
Okay, so typically the drying rate is 13 to 40 tons an hour, right?
But take in mind that's based on the 90-degree air.
90 degrees, so closer to 10 to 25.
Yeah.
Then we've got mobile dryers, and that's a very flexible option. Batch type dryers comes in capacities between 2 tons and 15 tons per hour, mounted on a wheeled chassis and can be towed between sites. As it's a batch dryer, and batches vary by model between 10 cubic meters and 100 cubic meters. Tell us how this works.
Okay, so these dryers are typically as a freestanding package, so it's a complete unit. It has loading conveyors, unloading conveyors, like I said, mounted on wheels. It's basically a silo that is built up. The silo sidewalls are made of perforated sheet, so that it allows the air and the moist air to come out. It's got a central conveyor running in the middle that is basically acting almost like a fountain mixer. It's picking up grain from the top and pouring it into the top, from the bottom and pouring it into the top, and that creates a flow and a mix in the dryer. And then you have just fans blowing air into the drying body to dry off the grain.
You can also use gas and biomass and coal and diesel to fire that.
Yeah, so you have all the fuel options on them as well.
And they're suited for smaller operations, I take it.
Depending on what your application is. Usually these will be for smaller applications, also for guys who maybe want to share, because it's a mobile unit, so you can move it between farms, you can move it between sites as and when you need it. So it's a lower investment, and it's possible to share the investment across a couple of guys.
And you don't need any infrastructure. You buy the system and you plug it in.
Yeah.
And go.
It's a plug and play on it. You don't need anything. You need 2 trailers, one loading, offloading, and one receiving.
Continuous tower dryers, those are mainly the commercial applications. Co-ops and central storage uses this. The capacities are higher, starting at 5 tons an hour up to 400 tons an hour. And of course, if the farmer brings in 500 tons of grain to be dried, from 18 to 13%, he's going to probably sit with a bill of 250,000 rands.
Yeah.
Okay, so there's money to be made for the central storage in this, but if your needs are that high capacity, then of course this is a thing you should consider.
Yeah.
How does that work?
So the continuous dryers, most of the modern continuous dryers would be what they call mixed flow dryers. So mixed flow just means the grain is tumbling over obstacles in the dryer as it passes through from the top to the bottom. That just basically mixes everything. And then you have the other part of the mixed flow is you have 2 different levels in the dryer. The top level, which would be the heating level. So you are drying the grain in the top level, heating the air up to there. We can go to 120 degrees Celsius because you have this continuous action, continuous mixing that's happening in the dryer. And as it tumbles down at the bottom, you have a cooling section where then cold air, or just ambient air really, is blasted through the grain to cool it down before it's exited it.
And these are basically modular units. So, these are stacked on top of each other to increase capacity, right?
Yeah. The thing with continuous dryers is they can't be run as batch dryers. They have to be kept pretty much full the entire time to work effectively. So you need to have a lot of infrastructure around that. You need to have a receiving place, a receiving pit for the wet grain. You need to have a wet holding bin that's continuously feeding into the dryer at the rated capacity. Then you also need to unload that dryer and get it back into the silo system. And most of the times it's a lot of conveyors that you have to put in, as well as the wet holding bin. So it makes the entire investment for using a continuous dryer quite expensive.
Capital costs are very high on these dryers in general.
Yeah.
And for commercial industrial purposes. So let's conclude this, and we say the type of dryer you select is depends on your need and application. For the on-farm usage, there's no doubt in my mind that a high temperature in-bin the dry stir system is by far the most effective, cost effective, and the easiest way to implement. You can use your existing bins. Remember, that's very important. You retrofit an existing bin with this. You don't need to buy a new bin for this purpose. So it's the thing to consider for this season.
Yeah, and as we said in the beginning, drying is expensive, but it can and will pay for itself in the long run, but not even in the long run, in the medium run. Really, it will pay for itself if you need it and if you want and if you actually use it.
Thank you. See you again soon in Hanging with Hubert.